We are honored to have architect Nikita Sahuji, the founder and managing partner at Eco Nivaran. With a master's in environmental architecture, Nikita is an accomplished architect and environmentalist. As the ISHRE Women Chair for 2023 and 24, an IGBC qualified professional and lead GA, she brings a wealth of expertise. Recently honored as the Budding Entrepreneur 2024 in Delhi, Nikita has 4 years of freelancing experience and served as the research and design head at the Environment Conservation NGO. Her contributions span authored research papers, a tree census app for a smart city, and a thesis on carbon crediting models. At Eco Nivaran, she leads a collaborative team for ESG projects, cementing her commitment to sustainable design and green building. Nikita will present a talk on sustainable architecture. So, let's welcome Nikita.
So it generally happens that we hear a lot about sustainability. So why not start with what is unsustainable? Why not understand first कि क्या नहीं करना है rather than क्या करना है? So I would like to start with that unsustainability is nothing but when the consumption done by we humans or the activities that we are performing is exceeding the ability that ecosystem can absorb. Whatever resources and all that we are consuming from resources, it is exceeding its capacity, and we are somehow putting nature and resources into jeopardy. So that is unsustainable state. Then I found this very interesting combination, interesting graphic where it says that whatever kind of lifestyle or whatever kind of resource consumption we are having at this date, how much the earth can sustain for that. So this one is a very interesting yet funny thing, that if the number of planets that we need to sustain the global consumption by 2050, if all the countries consumed, this is in comparison of Britain because we don't have a lot of data available with India, but similar, or I guess the worst situation must be there with India. I guess we are not sure about that, but then like we would use almost 1.5 times of the earth, or the land that is available to us right now, if we are consuming the same quantity of land that we are doing it now. And with in terms of energy, though it is worse, though we are shifting on the parameters of renewables and all, still there's a long way to go. It says that right now 6 7 8 8 8 point half 8.5 times earth you would need to consume the energy, like the to have the energy that we are consuming right now. So these all figures are very scary and very huge, but then let's come down to what can be done to sustain this. Coming to sustainability, we often define sustainability as a principle or as a practice or as a term where we are fulfilling today's need by not compromising on tomorrow's resources. And though we are as designers or as architects, we are talking about environmental sustainability here, but I guess that sustainability is a whole umbrella that covers environmental, social, and economic all together. It goes hand in hand, it cannot be segregated. Like even in practice we face the same thing. We talk about environmental sustainability with the client, the first question that client has it ki kya budget hoga. Then secondly, we need to see that whatever client is having, for example, if it's a bungalow or if it's a apartment building, are the tenants and all the people that are going to use the buildings are willing to adapt those environmental solutions that we are giving. So that's why it is very important that when you're talking about sustainability, we think it as in all three parameters, that is environmental, social, and economic. Without that, it cannot be concluded. Then bringing it to some statistics, because we always give our opinions. I guess it should be always supported with statistics. uh, Construction industry is the major contributor into emissions. Whatever we are talking about, climate change or greenhouse gases and all these big fancy terms that we are using, it all comes down to one thing, that is emissions. And here by carbon emissions we also include the greenhouse gas emissions into that. And these terms like embodied carbon, operational carbon, these are quite technical, but I would just explain it in a very simple way, that embodied carbon matlab, for example, if there's a product, if I'm talking about a mouse, so whatever energy that is consumed to make that mouse is can be considered as embodied carbon, and whatever energy is consumed to use that mouse can be considered as an operational carbon. And if we see the statistics, most of like 28% of the emissions are done when the building is operating, and 11% is done due to the building materials. That's why we see that there is lots of innovation and lots of development with new building materials and green materials and eco-label materials, because they are also contributing at a greater end. And with building operations, I guess the major chunk is due to the energy consumption of HVAC and all the air conditioning that we are using. So all this whole this impact that is generated by our construction industries, we can segregate it into three parts. That the three people who can help or who can contribute to mitigate this, it could be we designers, because it is considered that 70% of the environmental impacts that a building is going to cause are determined by at the level of designing or the building design level only. So we architects or we designers are very crucial part where we can reduce the impact of all this emissions on environment. Second comes engineer. I have just graduated in 2020, so I think that HVAC and engineering and MEP part still seems a bit difficult to me. So I guess engineers play an important part because they are people who are going to explain us how MEP can be efficient. And then third, the owner and the developer, or the developer, because obviously जिसका पैसा है उसका call है. So it is important कि they also are willing to contribute and move to more sustainable solutions. Coming down to sustainability in buildings, like sustainability in operations, in design, and coming down to sustainability in buildings, these are all the scattered words. The intention of these words being scattered is also symbolic, because all of these are dealt by different consultants and are functioning at different levels. But it is very important to have a network of collaboration in all this. This is the reason why integrated design approach has been a very crucial part in sustainability, because when all these things come together, only then sustainability can be achieved. I won't go into details of that, but let's come down to thermal comfort and energy conservation. Like if you talk about energy efficiency, just to simplify it, I try to make a flowchart out of it. So first thing is that we need to reduce on our consumptions, and second thing is then we think about shifting to renewables. Now both of these have their own complications, own implications. So when we are talking about reducing it in at the consumption level, what can be done? We can have energy efficient designs, and we can have energy efficient operations. So to have energy efficient design, we are having concepts of passive design or climate responsive designs, and there are lots of new materials and technology that can be induced to have the design efficiency. And when we are talking about energy efficient operations, where maximum buildings in India are like performing not very well, it is where we quantify what kind of energy we are using. सबसे पहला इंडिया में तो क्वांटिफिकेशन में ही गड़बड़ होती है. Even when we are working with other consultants, the major thing is to gain the data, to have to fetch the data, to quantify what is the current energy that they are operating, and then to monitor it, and then to convince them to improvise it. It often happens that when we show them the monetary benefit in their bills and all, only then they are convinced. But even after that, there is a task to train the staff, to have that skill expertise in the team who can actually reduce the operations of HVAC and the machineries and etc. And when we are talking about renewables, obviously it is about shifting to renewable energy like solar and wind. But even now, I myself live in a Tier 1 city like Aurangabad. So even here, the initial cost is a big hindrance for people to convince. And also the skill people that we require to install all these kind of systems. Though there are many companies who are providing solar energy and all that setup, but still there is a very backward mentality in tier 2 and the tier 2 cities about the renewable energy, that it and there are also many myths about it, that it doesn't give good consumption in winters, or whatever, there's a cleaning issue and all that thing. So shifting to renewables is still not very much adapted in tier 2 or tier 3 cities, and we are hoping after the recent Pradhan Mantri Yojana it may be accelerated. Now, instead of talking about the points, I thought that let's talk about the projects who are like explaining these points. So I am going to just show the three slides, the last three slides, which would be having my own project, and just I have, to give a very clear idea, I have written what is the intent to see this. So, for example, this was a bungalow. It is an architect's bungalow. The architect himself is designing it. Then he came to us. He wanted to do a green building certification, but then we somehow convinced him that because this is the first lead project coming in our city, let's make it passive as well. So we convinced him, and now we got the architect's design to do the analysis for daylight and ventilation. So this is what we call, this is a part of my microclimatic analysis report, where we are just analyzing the plan on basis of the daylight and the wind flow. So this is the approach that we are having, that in this no software is used. It is just on basic understanding that how sun is moving and how wind is flowing, and in what temperature, and in what seasons it is changing. So only on basis of that we are suggesting very small changes to the designer, which makes them very adaptable, because whenever the changes involving cost, वहाँ पे there is lots of like hindrance कि if the cost is increasing, the designer or the owner is not ready to change. So we also need to think about the economics, that it is not very expensive. So like for example, this was the bedroom. I won't go into detail of this. The designer gave vertical proportion में windows. So and also these windows were the long windows in terms of height. They were almost of 2 meters height window. So we just suggested them to make them operable at two levels. Just cut them at the sill level, have a different kind of window profile below and different kind of window profile above. Now what this will make it to in terms of cost also, this would be easier to operate because 2 मीटर का विंडो खोलने और बंद करने में हैवी हो जाता है. So even functionality wise it was good. And second, what we suggested him to have a perforated screen instead of window at the bottom and the top level. Now this was also climatically sound because the hot air would would exit from the above part, and whenever the air is coming from this part, because it is coming from small jali or perforated screen, it would have comparatively lower temperature, that what we call about Venturi effect. So these are the small concepts that we studied long back in our second third year in history of architecture, where we were thinking how Jaipur ka jharokas and how Hawa Mahal is made, but then it really struck that this can be done into modern bungalows as well. Similarly, in terms of he was having a huge window in his living room. So we suggested him to just divide this window into smaller slits, because it was not, we wanted maximum and a distributed light, because light coming from one source can cause glare, and also he had a TV unit here. So it was important to have a distributed and uniformly distributed light. So that's why we suggested him to just break the windows and divide it equally on throughout the wall. Similarly, this was the part where this is the south portion, right? So we generally have this mentality ki south maybe don't give lots of openings and all. So that architect also had the same mentality, and we convinced him somehow ki south and southwest direction is also our wind direction of our city. So we majorly need to get the wind inside, because Aurangabad's climate is very like hot and dry kind of climate. And he also had a staircase, which was a good thing because here we could help him to generate the stack effect. So similarly, so we suggested him to give punctures here and have a wing wall, which would help him to get the wind inside. And then also this portion has a skylight above it with a ventilator. So this creates a stack effect as well. So ऐसे तरीके से छोटे छोटे solutions देके it neither hampered his aesthetics, it also didn't increase the cost, and also convinced him to have more cooler space than what he was designing before. So this is where we do the daylight and ventilation analysis, and it plays a very major role in the operation, because somehow this space will be cooler and would use AC little bit less. Similarly, this was a second project where we were working on a bungalow with an office. It was again a CA's office.
Nikita, sorry.
So in this thing, what we did was we tried to design the shading devices, because Mumbai was again where we need to have the heat gain needs to be resisted, and we need to have crossly ventilated spaces due to humidity. So because for that only we helped him to design the shading devices by plotting the angles. So this can be done in software also, but this particularly we did manually, where we plotted each angle of the extreme temperatures and lower temperatures. So here we designed the shading devices for them. This was another project where we were trying to have a daylight in a library, because it is very important to have daylight in spaces like library. So this was the daylight simulation before, like in the existing daylight, and after our proposal, the amount of daylight that library was receiving this. And we gave very simple and small proposals to them, that just by changing the layout of the racks, if this was the existing where they were placed horizontally, and now we suggested to place them like this, so somehow increased the amount of daylight, or putting the reflectance on the wall outside, because this was in a basement, or designing the elements like light shelves or sun tubes. These all help to increase the daylight in that library. And lastly, I wanted to talk about what are sustainable townships, but I guess we are running lack of time. So in user townships, we have working on solars, we have lot of work on waste management, and lots of norms are there for the open to built ratio the ratio. So all that thing was seen in this one thing. I would request audience to later definitely explore about Magarpatta as a sustainable township. And at last, I would just like to say that sustainability cannot be designed. As designers, all we can do is inculcate it, but the users need to have that sustainable habits to be inculcated. So, as designers, we do contribute in inculcating those habits into it. But yeah, it is not only just limited to design, it has to be in operations as well. So I would like to end my session here. Thank you so much for the opportunity, and anyone can reach me at the given email address. Thank you.
Thank you so much, Nikita, for your enthusiasm in sharing the insightful submission on sustainable architecture.